Okay, boys and girls, now we're moving on to lesson 7.1, and we're still working with ratios, rates, tables, and graphs. We're going to add the tables, and we're going to add the graphs. So today, our essential question is, how can you represent real-world problems involving ratios and rates with tables and graphs? So that's what we're going to be working with, tables and graphs. Remember, at any time you can pause the video. Okay, here's model 1. It says students in Mrs. Cruz's class are doing an experiment. So here is the scenario. What is happening? In Mrs. Cruz's class, they're doing an experiment. This is what's happening. It requires 250 milliliters of water. And here's a key word. For every, this tells me it is a ratio. For every 5 milliliters of ammonia. And now, an ammonia is a product that we use in science and stuff like that. So, now the table below shows this. Okay? And so it's 250 milliliters of water for 5 milliliters of ammonia. And so we have that here. It's already written down. This is our ratio. This is our ratio. Now, what we need to find is what is the ratio of ammonia to water. So what is the ratio of ammonia to water? We have the ratio of ammonia to water is 5 to 250, or 5 over 250, or 5 to 250. And if you notice, it says ammonia first, and then water second, and then our keyword is 2. What is the unit rate for ammonia to water is question 2. So unit rate. We want to know what the unit rate for 1 milliliter of ammonia. If we get 1 milliliter of ammonia, how much water do we need? And that's what we're basically finding out. How much water to 1 milliliter of ammonia? Okay? And so now I'm going to go ahead and solve it down here. So we know we have 5 milliliters of ammonia. I think I spelled it wrong. And 250 milliliters of water. And I'm going to put my unit of measure here. ml, ml. We want to know for 1 milliliter of ammonia. And so if you notice, I put ammonia on top, and I also put ammonia on top. So I'm creating a fraction here. I'm creating a ratio in fraction form. And then we have water down here, and it's 250, but we don't know what or how much water we're going to need. So I'm just going to put a box there. I could put a question mark. I could put a variable. I could put anything there. And so how do I go from 5 to 1? How do I go from 5 to 1 when I multiply or divide? Would I multiply or would I divide? So from 5 to 1, I would divide by 5. And whatever I do on top, I'm going to have to do on the bottom. So I'm going to have to divide down here by 5. And this is a pretty simple one. So I'm going to get 250, so 5 divided by 5 equals 1. So if I was to do it like this, I'd get 1. And so now I have 250 divided by 5 equals, we don't know. So now I'm going to set it up, 250 over 5. And so I'm going to go ahead and start dividing. 5 goes into 25 5 times. It's 25. And I have bring down my 0. 5 goes into 0 0 times. So my answer would be 50. So when I came back over here, I would put 50. So 1 milliliter of ammonia is equal to, or I would need, 50 milliliters of water. And so question 3 says, for every 1 milliliter of ammonia, there are 50 milliliters of water. So for 6 milliliters of ammonia, and I can do the same thing here, ammonia. So if I had 6, so it's 1 over 50, and this is ammonia, and this is water, I would get, and it's asking me, what if I had 6 milliliters of ammonia. So how do I go multiplying or dividing? Would I multiply or would I divide to get to 6? Well, I would multiply. I would multiply 1 times 6 and I get 6, and 50 times 6 and I get 300. So if I had 6 milliliters of ammonia, I would have 300. 300 would go here. Now, let's look at our table. And so we start off with our ratio here. Okay? How do I go and complete this table? So now I need to find out this answer, I need to find out this answer, and I need to find out this answer. So the easiest way to do this would be to find the unit rate. And so if I did the unit rate here, okay, the unit rate, we already solved the unit rate. It's up here in question 3. So we know that 1 milliliter of ammonia equals to 50 milliliters of water. So it goes 1 to 2. 2 milliliters of ammonia would be 100. 3 would be 150. Now we don't have a 4 yet, but we're going to 3.5. So now we know that 1 to 500, or sorry, 1, because I'm doing this down here, and I can use my table, and so now I want to know for 3.5. So I'm going to put 3.5 here, and I'm going to put a box down here. So how do I go from 1 to 3.5? I multiply by 3.5. Right? 1 times 3.5 would give me 3.5. So then I'm going to multiply 50 times 3.5. And I'm going to come over here, I'm going to do it. 50 times 3.5, 0, 25. My placeholder, 3 times 0 is 0. 3 times 5 is 15. Add my decimal, or sorry, 0.571. And I move my decimal place 1 place. So it would be 175 milliliters of water. So it would be 175. And now this one's a little bit different. This one right here, it's going to be, so I'm going to just draw a line here. It would be 1 over 50. This is ammonia, this is water, is equal to 200s on the bottom, so 200 over a box. So how do I go from 50 to 200? I'm going to multiply by what? So I'm going from a smaller number to a larger number. I'm going to multiply, and I would multiply by 4. 50 times 4 equals 200. So whatever I do here, I have to do on top. So 1 times 4 equals 4. And I've completed my table. I've completed the table. Now at any time you could pause the video and continue, and I'm going to go ahead and pause. Alright, so now we're going to graph the ratios, and we're going to use the table that we did above. So I'm going to put 3 to 150, it's the same data. 3.5 to 175, it's 4 to 200, and I'll even put 1 to 50, just in case we need to have it. And so now we're going to create ordered pairs. If you notice, all I did was all of these numbers that were here, I put them in there. 3, 3, 3.5, 3.5, 200, 200, and so forth. So it goes 2 to 100, because the 100's here. 3 to 150, because it's right here. 3.5 to 175, it's right here. 4 to 200, and then we have 5 to 250. Okay, so now my ratios are 2 to 100. My ordered pair is 2 over 100. 3 to 150, and so my ordered pair would be 3 over 150, or 3 x and my y, x and my y. 3.5 to 175. My ordered pair would be 3.5 to 175. 4 would be 4 to 200, 4 to 200. My ordered pair would be 4 to 200. And my last one is 5 to 250. And my ordered pair would be 5 to 250. And so we have an X and we have a Y. We have an X. And so our X and our Y. Here's our X is always on this line right here. Our X is always on this line. This is always the first number in the ordered pair. First number. Here is our Y, and this is always our second number in the ordered pair. So we have X. So I'm going to highlight all my X's. 3, 3.5, 4, and 5. So now my goal is to plot these. I need to plot them here in my table. So I have 2. The first one I'm going to do is 2 to 100. 2 to 100 would be 2 goes to 100. I'm going to put a dot right here. Now I wouldn't draw the line, so I would take that away. The next dot that I would put would be 3 to 150. So here's my 3, and 150 is going to be right here because this is 150. This is 250. Okay. The next one is 3.5. So 3.5 is going to be in between the 4 and the 3. So this is my 3. It's going to be between the 4 and the 3. This is 3.5. And I'm going to go 3.5 to 175. So 175 is going to be right in between the 200 and the 150. Now I have 4. Here's my 4 all the way to 200. And if you notice, it draws, if I was to connect the dots, it draws a straight line. And I know my line isn't straight right now, but it draws a straight line. That's how we know these ratios are equivalent. So using this graph, could we figure out 1 milliliter of ammonia to how many milliliters of water? Well, let's find where 1 is going to be. One's going to be right here. So it's going to be right here. It's on the straight line. You see that it's straight. It's on that line. So it'll be about 50. And we know that it's 50. What about 0.5? 0.5 is going to be right about here. So where would this be at? This would probably be about 25. Okay. What about 2.5? 2.5 is going to be between 2 and 3. So if I did a line up here, it's going to be about 125. Okay, so I did our first example. I did Model 1 and Model 2. We will go to Model 3, but I'm going to put this on a different video. This is going to be on Part 2. And so you're going to have to go back onto YouTube and click on Part 2.